Recording.
Hello, welcome everyone. Good afternoon. So today we're going to have this training action in the scope of the B-WaterSmart project regarding one of the tools that were developed in the Lisbon Living Lab. Let me just share here the presentation. So we will present, as I was saying, one of the tools developed in Portugal in the Lisbon Living Lab which is the Urban Water Cycle Observatory of Lisbon. So everything is applied, despite it's a tool that is universal, can be universal and could be adapted to any city. It's already applied and specifically applied in Lisbon. Just to give you a very general scope of the cities that are involved in the B-WaterSmart project. And as I was saying, we are now talking about a Lisbon tool. For our agenda today, we will give you a brief idea what it's the concept behind this observatory. Mention the stakeholders involved in this data sharing that feeds the observatory, and go in detail about the two approaches that compose this tool. So in terms of the concept, the Urban Water Cycle Observatory is mentioned to systemize, collect, and facilitate access to data on the city water cycle level. So everything is meant to be specifically about the city of Lisbon. Its purpose is to have clear and transparent data to monitor. It's the basis of observatories to visualize and monitor, and to inform citizens. And this is one of the most relevant concepts behind an observatory, is to make everything clear, to supply not only data but information, because data has to be worked and transformed to be, as I said, clear and transparent. So the concept is also the main concept is to inform citizens. Now in the detail on the definition, it's a data visualization instrument which monitors and evaluates and communicates performance, and also provides some support to urban planning and decision making, as well as policy making, policy monitoring, etc., etc. It has a motto that is very, very clear and straight, is to know, so to reduce, or so to act. We have to know where are the consumptions or water consumption to better drive our actions and our attention, where are the main bottlenecks, the problems. And this observatory covers two environmental dimensions, let's say this way, water and wastewater, as well. It also monitors other environmental dimensions such as energy, waste, urban waste, mobility, and greenhouse gases in parallel. But today we will focus only on water and wastewater dimensions. Now, starting to go into detail on this tool, it has two complementary tools, let's say, a top-down approach and a bottom-up approach. This top-down approach is meant to provide open information, open data information on the water and wastewater city dimensions. So everything here in this approach is public. It's meant to be available for everyone. And the bottom-up approach for individual entities, so single users, let's say, to integrate and analyze their water consumption of their facilities, let's say. And in terms of facilities, could be buildings, could be gardens, could be garages, etc., etc. So could be any place that is monitored by a water meter. So regarding the top-down approach, this approach privileges the use of infographics to basically provide creative data to build awareness and engage and empower citizens. So as I said before, it is focused on informing citizens. It has a basis of in terms of design and data that is provided, the water matrix of the city, what comes in the city in terms of drinking water, what comes out in terms of treated wastewater. But I'll go in detail on this. All the data that is in this approach, all the public data, it's annual data, which we can update. Actually, we can update it very briefly. So we are now in February. We can very soon update 2023 year on this tool to have always updated data on this tool. So in terms of the data, as I said, it is the main water flows of the city. And since this is a top-down approach, we try to have the vision of the main water flows and then start to disaggregate these flows, this consumption, water consumption of the city by type of water source, by type of use, and by type of user as well. This also enables to develop indicators like per capita indicators, and on the side of the treated wastewater, the amount that is treated in each facility, in each wastewater treatment plant of the city of Lisbon, and what's the reclaimed water production and use. So this approach provides accessible and comprehensive and clear data, which allows the citizen city stakeholders to be informed. That's the main purpose, is to provide information. So for them to know their impacts and to feel motivated to and engage to participate and to somehow be more efficient. Going a little behind grabbing the motto is no to reduce again. And I have here also the two links for the two tabs of this top-down approach. Now, regarding the bottom-up approach, this just to take into account, this is meant for single users. So it's same thing. It's to monitor water consumption, but now it's not on the city level, but on single user level. So it monitors all the water meters of the facilities of a single user. So the more users we can get in the tool, the more we can have this bottom-up approach and to build the water flows in a bottom-up approach. So this is a web application which, as I said, integrates the water consumption of the user facilities with several characteristics on the facilities, if they are gardens, if they are markets, garages, gardens as well. And this tool specifically provides a set of data analytics on the data that the user integrates in this tool for a deeper understanding of their water use. So it's like depending on the data that we have in terms of periodicity. So we can integrate monthly data, daily data, and quarter-hour data. So the quarter-hour data, it's like let's say a fingerprint of the facility in terms of water consumption. This is it's meant to have a visualization of the water consumption per facility and its evolution, as I was saying. It also, depending on the characteristics of each facility, is possible to aggregate this information in categories per type of use, per water source, if it's drinking water, if it's gray water or reclaimed water, to have the associated costs and performance indicators. In terms of the facilities, for instance, water consumption per square meter in a garden makes a lot of sense to have this indicator. Or for instance, in a building, it could be the water consumption per square meter in terms of the area of the building or the number of people that work in that building, as an example. And this also allows the user to identify water efficiency opportunities and implement measures, as well then to monitor their impacts and check what was the impact of this measure. So this tool also allows to generate automatic reports based on all the data analytics that are presented that are made in the tool per facility. And also allows to set up customized alerts for specific consumption levels of each facility. For instance, if a facility, if the user thinks a facility should not have a consumption above 100, for instance, 100 cubic meters per day, it allows to set this alert and to provide also some analytics on these alerts. Now, the stakeholders that are involved in the data sharing for these tools, is actually two of them are part of the B-WaterSmart project. So in terms of drinking water, at city level, so top-down approach is the water supplier entity. And as well for the users level, it's the same entity, the water supplier. And for instance, could be also the private users if they have any monitoring themselves. In terms of the treated wastewater, is the wastewater treatment entity, which is part of the B-WaterSmart project, as well for the reclaimed water, and the municipality of Lisbon, which is also the Living Lab, Lisbon Living Lab owner. So we have also groundwater, which is provided by the Portuguese Environment Agency. This is still an ongoing work to see how we can feed and work this data to be provided in the observatory, and also spring water by the water supplier, which is not yet in use, but it will be in the future. So we built this top-down approach, already taking into account this water source. Now I'm going to skip for the websites. Let me just share here. Okay, so I'm going to start first with the top-down approach, which is this Urban Water Cycle Observatory of Lisbon. It's integrated in the Lisbon Observatories platform. So it's a platform, as I explained before. It monitors several environmental dimensions of concretely of the city of Lisbon, and we are going to focus only in these two, water and wastewater. And so regarding the water, it monitors what is the consumption of the city independently of the water source, and then starts to disaggregate all these details. So initially, since this is meant to be very simple and it's based in an infographic, we try to all the information that it's included here to be very clear and for anyone can be able to understand this data. So in terms of this top-down approach, it starts with the total consumption, water consumption of the city. Everything is annual data. So, for instance, in 2022, the city of Lisbon had a total water consumption of 53 million cubic meter. And in terms of per capita, each people had a consumption of 93 cubic meter per year. Now, going into detail, starting to disaggregate this data, we have the consumption, water consumption by water source. So we have potable water, treated wastewater or reclaimed water, spring water and groundwater. As I said before, the data is still ongoing in terms of work on how we can provide this and integrate in the tool, but we can see clearly the amount of potable water that is consumed in the city and treated or reclaimed water, and the huge difference that are among them. So there is a very big gap, and we'll see this later, and the potential of reusing this water in non-potable uses. Now, the daily average water consumption so this is the total consumption of the city divided by the number of residents of the city. So each people is responsible for a consumption of 280 liters per day in a generic view in terms of the city, counting with the not only domestic but commercial, industry, municipality consumption, etc., etc. Going into detail for the residential consumption. So this is only consumption inside households. It's 134 liters per day. So we use these two indicators. It's two very basic indicators, but that are widely used by the International Water Association to compare the consumption per capita in total consumption, domestic or residential consumption among cities. It's a very simple indicator, and that provides a very clear and simple data that everyone can understand, and to also to provide this is also an indicator that provides useful information for awareness campaigns, as an example. Now, the consumption by type of use, we now using the data that we presented before, the consumption by type of water source, and now by type of use, we have a mix of this. So we divided the uses of the city in residential, non-residential, which includes commercial, industry, institutions, etc., etc. Green spaces, and here there's the big opportunity of using alternative water source to the potable water. So reclaimed water, groundwater or spring water. Also urban hygiene, it's also a use that has the potential to be or to be done with an alternative water source, and other consumptions of the city. I would like to also to highlight here that the green spaces, despite it's only 4% of the total consumption of the city, this is over 2 million cubic meters per year. So it's still quite a lot in terms of volume. There are many cities in Portugal that don't even have this amount of consumption in the entire city. So it's just to have this volume of water for green spaces is quite a lot. So in here we can start to see the importance of using an alternative water source for these uses. Now, going into detail, in terms of the potable water consumption by type of consumer. In the graphs before, we were talking about the total consumption independently of the water source. And now, in here we are specifically going into the potable water distribution network or potable water consumption. And we can see clearly that around half of the consumption of the city is for residential. This was also clear here in the per capita indicator for 134 related with the 280. So this is pretty clear. In terms of commercial and industry, we can see, for instance, here the impacts of the pandemic effect actually in 2020 and 2021, which was the type of consumer that most reduced its water consumption. And we can see also the municipal consumption, which integrates the municipality, the smaller local authorities in the city, the parishes that are also responsible for a considerable amount of buildings and gardens in the city. So. And we can clearly see again the effort that it's been made over the last few years in terms of reducing this drinking water consumption in the municipal uses. Now the same information in percentage again, and I would like also to show this graph, this infographic, which provides the water consumption in each of the parishes of Lisbon. So it's possible also to compare in terms of spatialization of the water consumption among the parishes, and to evaluate which for instance, which parishes need to have more awareness in terms of residential consumption or more awareness in terms of industry or local accommodation or so on. So we have also the chart view, which also it's possible to clearly view the differences among each parish. Now, I'm going to switch for so this is the water tab. So it provides all the data in terms of consumption of the city. And now the wastewater tab is in terms of what's the amount of treated wastewater inside the city. So this is what is the treated wastewater that the citizens are and users of the city are responsible for. We can see also a bit of the pandemic effect here, and this provides complementing the water matrix of the city, provides what's the treated wastewater that goes out of the city. There are 3 wastewater treatment plants in Lisbon, and we integrate all the annual volumes that are treated in each of these plants. And again, having this in mind, we start to disaggregate again, so the top-down approach, to disaggregate this information in terms of what's treated in terms of wastewater that comes out, comes within the city boundaries or outside the city boundaries. In terms of total, we can disaggregate in terms of treatment plant, for instance, what's received in terms of wastewater that comes from the city and outside. And for instance, this one, Shellers plant, only receives wastewater from the city of Lisbon. And the same information, but now in a parallel view. So this is the data that we have public regarding of what comes out of the city in terms of water, and we can clearly see the potential of, and considering the amounts of wastewater that is treated in Lisbon, we can clearly see the potential of reusing this water for the non-potable uses. So this approach, as I said before, is meant to provide a very clear and transparent data to turn things public, because most of this data before were not public, or public in, let's say, in a report of the regulator of this sector, and it's not quite accessible to the citizens of Lisbon. And so this was designed to provide data and information for the citizens, and to make everything accessible and public, so anyone can consult this information. Now I'm going to skip for the bottom-up approach tool. So now it's a different platform which complements the previous one in terms of the water cycle. So we know we have the vision, an holistic vision of the city in terms of consumption. Where are the big major water flows or consumption. And now we look the other way around in a bottom-up approach and start to look at the users of the city which want to use this tool. And this integrates, for instance, I have, this is the dashboard, and have here, let's say, management test users to provide or to present the tool without any private data of the users. But this is real data that has been decharacterized, so no public information is no private information is shown, but this is real data, and this integrates all the water meters for a single user. For instance, as an example, this user here, this management test user, this tool integrates all the data, and then we can analyze this data in many different ways. We can check by consumption or by cost, and we can see it monthly data and in annual data as well. Having this in mind, when we integrate all the water meters of a user, we try to characterize these meters to provide as most information as we can in terms of what's the main use, where is where are they located, the address, in terms of location, in terms of mapping. Also the costs associated to this consumption, because they are different according to the type of user. And we start to build the other way around in a bottom-up approach. For instance, we know that selecting here 2019, this user has 23 facilities with a total consumption of 467,000 cubic meters in this year, and we can see the disaggregation by type of use or type of facilities, let's say, in terms of firemen, fountains, markets. I'm sorry, this tool was developed to be in Portuguese. But also in terms of gardens and the percentage of consumption. We can see the evolution of these categories, let's call it this way, in terms of annual data, and also the energy footprint and carbon footprint of this consumption. So the water supplier entity, this data is only drinking water. So for this test user, we didn't integrate any groundwater or reclaimed water. But for instance, this is calculated with indicators of the drinking water supplier for the user to know what's their impact in terms of energy footprint and greenhouse gases footprint. Now, going into detail, for instance, here in the gardens, we know we have eight water meters that are monitored in this user that this user has, and we can start to do some analytics on this, on the what's the minimum consumption, the average consumption of this category, the maximum consumption, and then same thing to check this the consumption in terms of annual data, its evolution. the biggest consumers, the lowest consumers, or all the facilities. And then, unfortunately, none of these facilities has one characteristic that we try to upload, which is necessary to provide or to calculate other indicators that are associated to this category, which is the consumption per, for instance, per square meter of area irrigated. And we could calculate this. It's not available here because none of these have this data, the area of irrigation, of green space irrigated, but that's also possible to calculate. Now, this was a wider view of the, let's say, the single use, which could be a municipality, could be an enterprise, could be a hotel, could be a parish. So we can integrate data from any type of user and to have this vision over their facilities. Now, going into detail on each individual meter, we also can do several data analytics on a single water meter. And I'm going just to select here the test user. You could see before that all the water meters are mapped. And I'm going to use here the 1 meter. So we can select, for instance, a water meter that's it's a real data, although here it's covered the name of the facility, but we can see that we can see here that clearly the monitoring had a huge impact on the water consumption of this facility. This specific facility was part of a program of water efficiency program in one entity. So all those water meters were under a program of monitoring, and there was it was possible to check the annual consumptions of this facility and the costs associated, and this was the result after the monitoring that was made and the water efficiency measures that were implemented. And this is the water consumption on monthly data, and we can see clearly the huge the huge reduction in the water consumption that occurred after this meter was part of a monitoring program. So this is a very simple and clear example of how monitoring programs or monitoring tools can have a huge impact on the consumption, whether it's water or electricity or something else. It's once again, we need to know in order to reduce or in order to act. And once we started to look, just to clarify, this is annual consumption, monthly consumption, and we can see here the daily consumption of this facility. And once we started to look at this and to understand that the consumption was too high, and we started to evaluate, does this consumption make sense or not? It didn't make, and several measures were applied, and I'm going to show you here the consumption back in 2015 and 16, and it was more or less flat consumption. This was specifically a building that had a leak, a water leak in the pipes that didn't came up at the surface, and it had for several years very high consumption due to losses. So after someone looked at the consumptions looked at the monitoring and evaluated that consumption, that didn't make any sense regarding the type of uses that the building had. And after the efficiency measures, the consumption reduced from 130, around 130 cubic meters per day, to 14, 7, 7 again. So we can clearly see the huge impact this have. To look at the data. Now, in this tool, all these graphs can be downloaded as well for CSV or PDF or PNG. So, and regarding this evaluation or this data analytics over a single meter, we can go even into a more detailed analysis. For instance, this is a meter that has only monthly and daily data, and the data analytics go as forward as they can in terms of this periodicity of the data. We have a comparison of the monthly data of the last. We can switch here, for instance, for 2019. Of the last 12 months and the previous 12 months as well, to compare among the same months. In terms of daily data, we are seeing August of 2019. Of course, this is updated daily. We could have the data from yesterday. But in terms of daily data, we can see for a specific month the water consumption per day, and see the effect or the progress in terms of days of the week and weekends, and clearly see the reduction that in terms of the use of this building has on Sundays. Now, in terms of days of the week, this graph compiles all the Mondays, all the Thursdays, all the Wednesdays in terms of days of the week, in terms of Saturdays, and in terms of Sundays and holidays. We can see the path among the days of the week. Same thing for alerts. This facility doesn't have any alert actually. And finally, in terms of the energy footprint and carbon footprint, we can see for this specific facility, we can see the impact. Well, very similar, because it's a direct calculation, very similar to the water consumption evolution. We can see the impact on it had in saving also the related energy and carbon emissions that are related to this water consumption. I can now can show as well other examples of water meters. This happened the same thing. So a very high consumption over 100,000 cubic meters per year, so quite a lot for a single facility. And after in this program, after we look at the data, we start to analyze this data and to deeply understand this consumption, and to see that this didn't make any sense comparing to the common uses of this facility. And then it was possible also to find leaks in this facility and to repair it, and we can see the effect it had after the repairing of the leaks. So once again, if no one looks at this data, this could continue for on and on until now. So this is the importance of monitoring, and to have someone looking at this data. This cannot be just a bill which is paid and no one looks at it. So it's how much important it is to look at data. And since this tool aggregates and it's fed automatically in terms of the water data, it facilitates a lot a user, for instance, responsible for a building, for instance, this one, or responsible for a garden, a manager, to have access to the water consumption data of its own facility, to better manage, to better know the impact of the measures that they are implementing in that facility. For instance, if in a garden, if the distribution network, the water distribution network has a problem, has a leak, we can see. Let me just switch here for another water meter. This one has quarter hour data. This is clearly a garden regarding the evolution of the consumption in the summer months, and we can clearly see. Let's just go here to the detailed consumption. We can clearly see here. I'll show the graphs again, but for instance, here we can, let's just go a little behind. So if a manager wants to change the irrigation schedule to increase or to decrease, it can see with quarter hour data. This is just an example on how this is important, to have this data for a manager to have access and to have this available for the management of the facility or the garden. This concrete facility is it's a garden that we could see by the path or the evolution of the consumption, and to see the quarter hour data of we are seeing Monday, or we can see Tuesday, but all the Tuesdays of the month, the consumption in the 24 hours. So he knows when the irrigation starts, the schedule, and can see how much water is spent, when it starts, when it ends, and to check also the impacts, as I said before, the impacts when he changes something in the management of this facility. Rather, it is an increase in terms of irrigation schedule, or repairing a leak in the pipes, or whatever. It is meant to provide a manager all the information, all the detail, all the, let's say, as I said before, the fingerprint of the water consumption of a facility. And with quarter-hour data, it is possible to do it so. So this facility here has these two additional analytics, which is not possible with daily data. So in terms of the 24 hours, we can compare all the 15 minutes of a month, comparing it with the previous month, or with the same month of last year, and check the differences in terms of its consumption, increase or decrease in these 24 hours on average. And as I presented already before, the daily consumptions per day of the week in terms of, again, in terms of the 24 hours. So this is, I'm going to stop sharing now. But in terms of these two tools, they are meant to provide data and information for different kinds of stakeholders, for citizens, public information, which also is very valuable to support policies. For instance, the Lisbon Climate Action Plan, or so on. Other cities also have it, and the measures that they are including in these plans, or sustainable energy and climate action plans, whatever. This tool also supports, or it's a help monitoring these kind of plans and policymakers to know what they are in terms of the measures that they are including these policies, to support them monitoring this, not only the having a baseline, and as well having a monitoring of these dimensions in terms of water consumption or energy consumption or greenhouse gases, for instance. It's a support to policies as well. It's a tool that can monitor in these terms, monitor aspects of several aspects of policies. For instance, another concrete example, plan to reuse water in a city. We can clearly see here in the public data the amount of water that is reused in the city of Lisbon. So it supports policies as well, not only but it's the main scope to provide information to citizens and make everything public. And summarizing, the other tool which helps single users to have a better understanding of their own consumption. It made sense. These tools made a lot of sense to entities that have a lot of water meters, for instance, municipalities, to know where they spend more water, and how to act towards this issue, how to plan, and how to what measures to design to tackle this issue. So this was what I had for you today regarding this tool, which has these two approaches. And now I see that there are already someone trying to ask things. I'm going to skip now for the questions part, and I would like to hear Paolo, what comments or questions do you have? Yeah, you have the word. Mm, okay. So we are not having any response from this participant. No. So I would like to give the word to anyone that wants to ask any question. Okay, I'm going to give the word to Pedro Teixeira.
Hello, Rui.
Hi, Pedro.
First of all, thank you for your presentation and your webinar. This was really, well, like the observatory is very clear and objective. And I would just like to say that this is a tool that we have been using in the Lisbon municipality. And in fact, it's very useful. It's a particular tool because the observatories are useful for municipalities, but also for the common citizen. So that's really, and it's really useful for us. I would just like to say that.
Thank you, Pedro.
From both approaches, the top down and the bottom up.
Okay, thank you. I don't know if anyone has any additional question. Just one, I would like also to clarify one thing, which was one of the bases of these observatories, mainly the public part. So probably 10 years ago, we annually updated the energy and water matrix of the city. So these two matrices were updated annually, and it was a document that was disseminated and made public with almost all of these informations. It was slightly different, but the in terms of reaching citizens and reaching many kind of community, universities or investigation, so on. It was quite tricky to have this reach with a document, and so we felt the need to update this for a public platform and to provide all the data and to make things public and for everyone. I don't know if anyone wants to ask anything. So if not, I think we can stop here. I would like also to share with you that we have an online form for the evaluation of this webinar. I'm going to share this here in the chat. I'm going also to share here the the links of the tool, the water and the wastewater dimensions, and to just a moment share here the link of this form for you to fill and provide us with some feedback regarding this webinar. So I would like also to thank you all for attending the webinar and hope this was useful for your work as well. Yeah, so thank you and have a nice afternoon. Thank you.